Greetings, beautiful people. Welcome back to Fine XYZ. If you are new to my channel, any DM, subscribe it. What I say, kindly subscribe. We are still on the road to WASSCE 2026. Let's try this problem. The volume of a hemisphere is increasing at a rate of 21 centimeters cube per second. We have been tasked to find the rate at which the radius is increasing when it is 5 centimeters. Let's dive in. What is a hemisphere? A hemisphere is half of a sphere, and we are talking about volume. Since the volume of a hemisphere is half of the volume of the sphere, we need to know the volume of the sphere. The volume of the sphere is 4/3 pi r cubed. Now when we take half of this, which is 1/2 of 4/3 pi r cubed, we are going to get 4/6 pi r cubed, and this simplifies to how many 2 are in 4? That is 2. How many 2 are in 6? And that is 3. So we have 2 out of 3 pi r cubed. This represents the volume of the hemisphere. So volume of the hemisphere is 2/3 pi r cubed. The volume depends on the radius. So if you have a very small radius, it means that the volume will also be very small. If the radius is big, it means that it will affect the volume. So the volume of the hemisphere depends on the radius. Then how is the volume changing with respect to the radius? So let's find out. That is the v, the r, since v depends on r. Now in differentiation, we know that if I have x to the power n, the n will come and multiply the variable, and I will subtract 1 from the exponent. So we are going to do the same thing here. I'll bring my 2/3, since it's a constant, does not change. Pi is also a constant. Now r, which has power 3, will now come here and multiply this. Then it will reduce by 1. So we are going to have r3 minus 1. Then 3 divided 3. So we are left with 2 pi. What is r? Now this is 3 minus 1. That will give us r to the power 2. Since when you differentiate volume, you get an area, this we should add centimeters squared. So this represents the rate at which the volume is changing with respect to the radius. But we were given another thing in the question. We are given the rate at which the volume is changing with respect to time. So that is the v, the t. We are given the v, the t as 21 centimeters cube per second. So it means that this is the rate at which the volume is increasing. In every second, it increases by 21 centimeters cube. And we will be tasked to find the rate at which the radius is increasing. So because if the volume is increasing, obviously, then the radius should also increase. But at what rate? That is the r, the t. But watch this. We have quantity of volume, another quantity which is radius, and we have another quantity which is time. How do we combine all these quantities? That is why we need a chain. We need a chain to link all these quantities together. So I can write the r, which is on top, then I'll bring a boss that we don't know times a certain boss that we also don't know over the t. We have radius, we have time. What is the missing piece? That is volume. So I will just substitute the v on this side and another the v on this side. Now we have been able to combine the 3 quantities with the help of a chain rule. So this is what we call chain rule. The chain rule is linking all the quantities together. That will help us find the rate at which the radius is changing. Then obviously we know the v, the r, but we don't know the r, the v. This is the r, the v. Since we know the v, the r as 2 pi r squared centimeters squared, then obviously you see the r, the v, you see the v, the r. One is the inverse of the other. So I will just find the inverse, and this will be 1 out of 2 pi r squared centimeters squared. Now I have everything set up. I have my dr, the v, I have my dv, the t, which was given in a question. So I will just substitute all these things to help me find the rate at which the radius is increasing when it is 5 centimeters. So let's do that. The r, the t is equal to the r, the v, which is 1/2 pi r squared centimeters squared, times what is the v, the t? That is 21 centimeters cube per second. Now watch this. If I have centimeters cube divided by centimeters squared, from our indices class, if the bases are the same, we can equally subtract the exponent. So this is centimeters, then to the power 3 minus 2, and that will give us centimeters. So it means that the centimeters square and the centimeters cube will give us centimeters. Then we have our 21 divided by 2 pi r squared. So the r dt will be 21 over 2 pi r squared centimeters per second. However, we know radius is equal to 5. So it means that we have to substitute the value of the radius to know the rate at which the radius is changing when the radius is 5. So we'll just substitute that. So we are going to have 21 over 2 pi multiplying 5 squared centimeters per second. What are we going to get? 5 squared will give us 25. 25 times 2 will give us 50. So the r, the t, when the radius is 5 centimeters, you are going to get 21 over 50 pi centimeters per second. This represents the rate at which the radius is changing when it is 5 centimeters. That is all I have for you, ladies and gentlemen. If you found this useful, kindly leave a comment, share this video to all your friends, tag at least 10 friends in the comments, and I'll be back with another video. I'm out.